So zeros of polynomial functions are x values that make the function 0. So for example, f of x is x squared plus x minus 2, which can be factored into f of x is x minus 1 times x plus 2. When x equals to 1, this term is 0, so that makes the function 0. Also, when x equal to negative 2, this part goes to 0, so that makes the function also 0. So 1 and negative 2 are zeros of f of x. Sometimes it's also called roots. That's the same thing. So f of x has these two zeros, and also we can say that x minus 1 is a factor of f of x. X plus 2 is also a factor of f of x. So here's the factor theorem. So for any polynomial function f of x, x minus k is a factor if and only if f of k is 0. So if f of 1 is 0, then we can say that x minus 1 is a factor, and vice versa. So let's look at a few examples. So let's determine whether x minus 1 is a factor of these polynomials. So x minus 1, we're gonna test f of 1. So f of 1, we plug into the first one, so 2 times 1 to the 4th, plus 3 times 1 squared, minus 5 times 1 plus 7. So the result turned out to be 7, which is not 0. That means x minus 1 is not a factor. It's not a factor of f of x. That means we cannot write f of x equal to x minus 1 something at all, times something. Alright, let's look at b. F of x is this, and we plug in the 1 into x's. So it turned out to be 0, so that means that x minus 1 is a factor of this. X minus 1 is a factor of this polynomial function. And that means we can write f of x equal to x minus 1 times something. And to find this, we can divide this by x minus 1, like we did in the last section. Here are a few more examples. So determine whether x minus 1 is a factor of the polynomial. So we test for x equals to 1. So f of 1, we just plug in to this function, and it turned out to be 0. So that means x minus 1 is a factor of this one. So in this case, we can write f of x is x minus 1 times something. Right, so for this one, x plus 1, we're testing for x plus 1. So that means the value of x would be minus 1. So that's why we do f of minus 1. Minus 1, so we plug in here, so 2 times negative 1 cubed plus negative 1 plus 2. So it turns out to be negative 1, which is not 0. So that means x plus 1 is not a factor of this function. In this problem, if we're given that negative 3 is a 0 of the function, then we can conclude right away that x plus 3 is a factor of f of x. And in order to factor this, then we can just do the synthetic division that we learned last section. So the function divided by x plus 3, and the remainder should be 0. And the result is x plus 3 times 6x squared plus x minus 1. So this is similar. 3 is a 0, that means x minus 3 is a factor. So we can divide the function by x minus 3, and we get the result to be x squared plus 2x plus 2. So we can write f of x is x minus 3 times x squared plus 2x plus 2. We can also determine the zeros for a function by looking at the graph. So this is a graph of f of x. It touches the x-axis at 4 location. So that's where the y value is 0. So the function value is 0 at x equal negative 2, negative 1/2, 1/3, and 1. So that means negative 2, negative 1/2, 1/3, and 1 are zeros of f of x. So that means x plus 2 is a factor, x plus 1/2 is a factor, x minus 1/3 is a factor, and x minus 1 is a factor of f of x. So how many zeros can a function have? So a polynomial function of degree n can have at most n distinct zeros. So degree 2 polynomial can have at most 2 distinct zeros. So for example, for linear function f of x 2x plus 5, that's degree 1, so it can have at most 1 distinct zero. So a line can only pass the x-axis one time, so that's why it can only have at most one root. It can also have no root at all, like in the case of a horizontal line that's parallel to the x-axis, so it never touches the x-axis at all. So in this case, that would be no root. So for 2 degree polynomial, it can have at most two distinct zeros. So in this case, it would meet the x-axis twice. In this case, it would meet the x-axis only at one point only. In this case, it never touches the x-axis at all. In this case, there would be no root. So for a polynomial function of degree 3, you can have at most 3 distinct zeros. So this special case, f of x is x cubed plus 3x squared plus 3x plus 1 can be written x plus 1 cubed. So that means that's x plus 1 times x plus 1 times x plus 1. So the x plus 1 factor 3 times, right? So, but there's only one distinct zero, which is negative 1. That would make the function 0. So that means we call this, the minus 1, 0 has a multiplicity of 3. So the multiplicity of the 0 means how many times it is a factor of the f of x. In this case, it's 3 times. So if we want to find a function of degree 3 that has these 3 zeros, negative 1, 2, and 4, we can write that function as x plus 1 times x plus 2 times x minus 4, because negative 1 is a 0, 2 is a 0, and 4 is a 0. So we can write these factors. And since it's degree 3, that means there's no more x. So this is x already 3 times, so that's x cubed already. But we still need to have a in front, because a is a real number that we don't know yet. And these factors can make the function 0. It doesn't matter which a. But if we're given extra information, like this one, f of 1 equals 3, we can use that to find what a is. So in this case, let's plug in x equal to 1 into the function. So that's 1 plus 1, 1 minus 2, and 1 minus 4. And the value of f of 1 is 3. So that's 3. So then turn out a to be 1/2. So I mean the function that we're looking for with these zeros and this information is f of x is 1/2 x plus 1, x minus 2, and x minus 4. And if we simplify, multiply out, and simplify, we would get this function. In the second example, this function has negative 2 as a 0 of multiplicity 3, and f minus 1 equals 4. So negative 2 multiplicity 3 means that x plus 2 is a factor 3 times. So function is a times x plus 2 times x plus 2 times x plus 2. And in order to determine the a, we can use the additional information, f minus 1 equals 4. So that gives us a to be equal to 4. So the function then is f of x is 4 times x plus 2 cubed. Go ahead and try these and check the result. So this one, zeros of negative 3, 1, and 4. So that means x plus 3 is a factor, x minus 1 is a factor, and x minus 4 is a factor. And determine a, we use the f of 2 equal to negative 20, and turned out a to be 2. So f of x is 2 times x plus 3 times x minus 1 times x minus 4. So for b, so both are function of degree 3. So for b, 0, 2, and 0, 4 have a multiplicity 2. So x minus 2 is a factor, and x minus 4 is a factor 2 times. And determine a using this fact. So we get a equals to 2. So f of x is 2 times x minus 2 times x minus 4 times x minus 4. of x is 2 times x minus 2 times x minus 4 squared.